All right, in our second video today, we're going to be talking about angles. So when we're graphing these angles, this isn't something you've probably done before. We're graphing these in what we call standard form, and this is going to get us ready for some things that we have later on in this unit. So in my picture over here, I have a couple things labeled. The initial side of our angle is always going to lay on the positive x-axis here. So this is the initial side. And then the terminal side of our angle is where it lands, basically. So the angle is formed between these two sides. Okay, and we're always going to have an arrow here to show the direction that the angle has actually opened up. Because we're going to have counterclockwise and clockwise rotations. So when we move in a counterclockwise direction, like the one in the picture here, that would be considered a positive angle. Clockwise rotations are going to be negative. So you can see we start at 0, we go to 90 degrees, 180, 270, and then we would get back to 360 here. So as we move counterclockwise, we have positive angle measurements. All right? So we're going to just sketch a couple of these. Right? And these are not going to be perfect. We just want to make sure that we get it landing in the correct quadrant. So I know that it's going to start on my positive x-axis, and 75 degrees would land just shy of the 90-degree mark, which is going to be that positive y-axis. Now, negative 160, so let's mark it like this. I know this is 0. This would be negative 90, because we know a negative is going to make us go clockwise. This would be negative 180 degrees. So I know negative 160 is going to be somewhere over here. Right, so I have my initial side, my terminal side lands in between negative 90 and negative 180, but closer to negative 180. And this time our arrow is going to show that it opened clockwise. Now, anytime you have an angle greater than 360, that means that we have gone one full revolution around and then some more. So it's positive, so I'm going to start where I always start, and I'm going to go around one full time. Now, as I go around, I know that once I get back here, I'm at 360 degrees. I have to go to 430. Well, 360 plus 70 more degrees is going to get us to 430. So I'm going to land about right here. Okay, I'm going to land inside of the first quadrant. So when we go more than 360 degrees, we're going to have this kind of spiral arrow show up to show that we went all the way around and then some more. Now, the next thing that we like to talk about here is radians. You've probably never used radians before. Radians is just another way to measure angles. I'm not going to go into too much of the detail here about what a radian actually is. Just kind of think about it as the difference between measuring something in inches versus centimeters. Okay, it's just a different unit of measurement for angles. Now, what we're going to do a lot of is converting between degrees and radian units. And this is the information that's going to help us do the conversion. Okay, so that's what we have in these next couple examples. We're just converting from one unit of measurement to another. And we can talk about what radians are in more detail during class. So let's say I have degrees and I want radians. Well, if I know that there are 360 degrees in 2 pi radians, then I can convert this. It's kind of like doing dimensional analysis. I have degrees, I'm trying to get rid of the degrees, and I'm trying to change it into radians. So what I'm going to do is I'm going to put what I start with over 1, and I'm going to multiply it by pi over 180. Right? If we're looking at the units here, my unit of degrees are going to actually cancel out with each other. Having pi in our answer tells us that we're measuring in radians. So to actually find the radians, what we're going to do is multiply this all together. So we would get 30 pi over 180. And then we can reduce 30 over 180 to 1 over 6. So this would reduce to pi over 6. pi over 6 is the same as 30 degrees. All right, let's say we have negative 220 degrees. I'm going to do the same thing. I'm going to put negative 220 over 1, and I'm going to multiply it by pi over 180. Pi goes on top because that's the unit I want to finish in. Degrees goes in the denominator because I want these degree units to cancel each other out. Okay, so now, same thing again, I'm going to multiply across. So I get negative 220 pi over 180. And then we can reduce to get negative 11 pi over 9. Okay, we always want to keep pi in our answer when we are converting things to radians. Now, if I want to go the opposite way, if I have something in radians and I want to go to degrees, I'm still going to take what I start with, but this time I want the pi to cancel out. The pi is what's telling us that it's in radians. So we're going to flip what we multiply by. I'm going to put pi in the denominator now and 180 degrees on top because I want the unit of degrees to be what I end with. And when I put my pi in the denominator here, it's going to cancel with the pi in the numerator. And then what we're doing is just multiplying things together, like 4 times 180, divide all of that by 3, and we end up getting that this is 240 degrees. Okay, negative 5 pi over 36, we're going to do the same thing. Take what we start with, multiply by 180 over pi. The pi's cancel out. So we're left with that unit of degrees. When we multiply everything together, we end up with negative 25 degrees. Right, so check in your calculator, make sure you're getting those same numbers, make sure you're doing your calculation correctly here. Now, if you flip over, we have a couple more examples of some special types of angles that we're going to be interested in moving forward. We have what are called coterminal angles, okay, which are angles that are in the standard position, okay, the standard form, with the same terminal side. Now, remember, the terminal side is where it lands. So what I wanted to show you here is that all 3 of these sketches on your page have the same exact terminal side. They are all landing in the same position, but they have different angle measurements associated with them. For the first one, we have a positive angle measurement of 60 degrees. Then we have a negative 300 degrees. And then we have a positive 420. Right? These are all considered coterminal angles because they have a common shared terminal side. Okay? Now, the easiest way to find coterminal angles is by taking your original angle and just simply adding or subtracting a full revolution, which is 360 degrees or 2 pi, to your original angle, right? So for example, if I start with 60 degrees and add 360 degrees to that, I end up with my angle measurement of 420. If I start with my 60-degree angle and subtract 360, I get a coterminal angle of negative 300 degrees. So you can always find coterminal angles by adding and subtracting revolutions. The other type of angle that we want is going to be called a reference angle. Now, these are the rules for reference angles. They have to be positive, acute, right, so less than 90, and they always have to measure back to the nearest x-axis. So in this little sketch here, if this is my angle that was sketched, the reference angle is not actually the measurement between my initial and terminal side. It's measuring my terminal side where it lands back to the nearest x-axis, right? This angle right here, I'll just call it x, would be my reference angle. It's acute, it would be positive. We're measuring the terminal side back to the x-axis. Okay, so for this example here, this is our last one, we want to sketch the angle and then we want to find a couple things. So if I'm sketching my angle of 225 degrees, remember this is 0, 90, 180, 270. Now it starts here. 225 is going to be in between 180 and 270, right? And here's our little arrow to show which way we went. We want to find the reference angle first. So we're measuring our terminal side back to the nearest x-axis. So I would be measuring here. Okay, this is our reference angle. Now keep in mind, right here is 180, so we just have to find how far do we go from 180 to get to 225, which is where this landed. Okay, so if we just find the difference there, that would tell us that our reference angle is 45 degrees. Okay, and we can check. We know it's supposed to be positive and acute, right? 45 degrees meets those requirements. Now, we also want to find a positive and a negative coterminal angle. So for a positive coterminal, what I can do is I can take my original angle of 225 degrees and I can just add a revolution, which is 360 degrees. Right? If I add those together, that gives me 585 degrees. So again, coterminal angle means that if I were to sketch 585 degrees, my angle is going to have a terminal side that lands right on this terminal side here. To find my negative coterminal angle, kind of abbreviate, oh, that's a horrible M, I'm going to do the same thing where I'm going to start with my original angle, but this time I'm going to subtract a revolution. Right? This is going to result in a negative angle measurement of negative 135 degrees. Okay? So now we would have everything you need. So that's it for this video. The next section is going to start getting into some more new stuff. Have a great day.